Hi all, today we will be discussing the solutions for assignment 10. As usual, we'll start off from the first question. Which of the following is true for an 8-bit 2's complement number? So the range of an 8-bit 2's complement number can be written like this: minus 2 power n minus 1 to power n minus 1. Therefore, it is, uh, 2 power n minus 1. Sorry, the value is 2 power n minus 1. So 127. Right. So the answers are 127 and minus 128. Uh, I mean, if you want to know how this is happening, it is basically one followed by all zeros. 1, 2, 3, 1, 2, 3, 4. This is minus 128 because this is 2 power 0 to 2 power 7, but this is minus. The highest power is minus, right? So minus 128. And the inverse case, the highest possible value that you can obtain is nothing but 0 followed by all ones. 1, 2, 3, 1, 2, 3, 4. This basically is 128 minus 1, because if I could get one more one, it would be 128. This it will be 128 minus 1, right? The previous number 127. Therefore, that's how you get the answer. Question number two. Uh, m- m- Values. So you have two numbers that are being multiplied, and you're asked it. The options are, if both are are signed numbers, are unsigned numbers, what will happen? So if both are signed numbers, like you see over here, right? It is minus 2 power 7 plus 1 is the first number, and minus 2 power 7 is the second number. This is your answer for if if it is signed number, signed 2's complement number. If both are unsigned, it is 2 power 7 plus 1 into 2 power 7. So this is your answer. So therefore, your answers are 16256 and 16512. Question number three. Given a 6-bit 2's complement number, what is the smallest value that can be obtained if the MSB bit is fixed to 1? If the MSB is fixed to 1, the smallest value you can obtain is if you have all others to be 0, which is minus 32. Given a 2's complement number p equal to 1011, if p into q is equal to p square, then what is the value of q? So this is very simple. You can just write down this expression and say that if p is either 0 or p is equal to q, then the value of uh, 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 yeah. So in this case, uh, it satisfies only when p equal to q, because if p was 0, it'll be like 0 equal to 0, right? So uh, or the other way to think about it is, q is equal to p is your answer, and q is equal to 1011. Now you sign extend that will be this, because any 2's complement number can be sign extended infinitely on the left side. Okay. Question number five. Which of the following are true? Exactly, it utilizes the property that I mentioned before, right? Sign extension on the left hand side, how many ever times will work, will be as you can find this in the lectures, right? Now, if it is an unsigned number, you cannot sign extend it with one. You should extend it with zeros, because you should not assign any value to that particular power. Basically, let's say if this was 2 power 0, 1, 2, 3, 4, 5, 2 power 6, 2 power 6 into 0 will still be 0. Therefore, you cannot extend it with 1, you should extend it with a 0. Question number 6. How many full address are required in a 8 cross 8 multiplier? So here, you know that this an 8 cross 8 multiplier, 8 into 7. So it's a 56. So many full adders are required. Basically, you just need to look at how many full adder tiles are required. Just go back to the example that was given in class for a 4 cross 4. You would find that 4 into 3 would be the answer, 12 full adders. You can extrapolate and obtain it for the 8 cross 8 as well. Question number 7. What is the critical path delay for an 8 cross 8 array multiplier given t and is equal to 1, t carry equal to 1, t sum equal to 3? So, first of all, you need to find out what is the critical path in this configuration. The critical path would be, since the carry is what is being flushed all this way, and the sum is what is being flushed down the path in the vertical along rows. Along columns, it is the carry. Along rows, it is T sum. And again, along columns, it is T carry. And then finally, T sum. So you have one T and mm, mm, uh, seven T carries, again, six T carries, and seven T sums, and one T sum here. If you add up all those numbers, you will get 35. Right? So the way to determine the critical path is basically the path that has the largest delay. In the sense, here you have six T sums all the way down, which is contributing to delay, as well as several T carries. And in the final stage, you should look at the T sum because T sum is greater than T carry. Therefore, 35 is your answer. Question number 8. What is the critical path of a 8 cross 8 carry save multiplier with a ripple adder as the vector merge stage? Right. So in you can go back and refer if T carry is greater than T sum as explained in class. This will be your carry save multipliers delay, which is 1 T and on top m minus 1 T carries plus T merge. Right. The T carries is what is propagating down as opposed to in this case it was the T sum. In this case it will be the T carry which is propagating down. So T and plus m minus 1 T carry plus T merge. Right? The T merge is nothing but T carry plus T 7 times T sum. T merge is nothing but the final ripple adder that is going through. Right? Uh, yeah. So in this particular example, T carry and T sum both are one, so it doesn't matter. If the other case exists, it depends on in the ripple adder whether you should look at the sum or final stage also you should look at the carry. Right. So see, this is C out and this can be S. Right. So T carry into 7 plus T sum or 8 times T carry depending on what is given. But here it's 1 1. Hence the answer 18 holds. Okay. Question number 9. When performing 8-bit 2's complement multiplication, how many full adders will have one of the inputs tied to logic 1 using carry save multiplier? So for this, go back and look at the lecture videos. For a 4-bit example, you will see that only two of the full address will require tying the logic to be 1. And if you extrapolate and add another row for another bit, let's say a 5-bit 2's complement multiplier, you will again see that only 2 is needed. So the answer always remains to be 2. Question 10. Mark the statements which are not true. Right. So the statements that are not true is carry save is chosen for lower area. No, it's chosen for lower delay implementation. Why? Because you're trying to pass the carry forward. Right. Instead of rippling it through, you're trying to pass it through the next stage. Then the carry bit in one row is propagated to the following row of the adders. Is exactly true, right? So carry bit is in one row is propagated to the following row in a carry save multiplier. So in order to save delay and area as compared to the array multiplier in total, because you need to save area as well as delay, you're going for the carry save multiplier. The saving is in delay. So carry save is chosen for the delay, right? Therefore, this is true. Uh, 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 Sorry, what I meant was option B, uh, which is it is chosen for the lower delay as well as for passing the carry. It is not for the lower area. The area is basically the same, right? It depends on it's only the matter of wiring that changes. So either whether for the sum to propagate or for the carry to propagate. So it's chosen for the lower delay implementation. Therefore, not true. No, this is not true, not true. Okay. Yes, if you have any more questions on assignment number 10, please let me know in the comment box. Thank you.